spoke to you about what is a wave. So, Harvish, can you please unmute yourself and tell me what is a wave? Harvish, come on.
Sir.
Yes, please.
Wave is a disturbance which will travel from one place to another, sir.
Okay, wave is a disturbance or wave is a pattern in which the energy is traveling from one place to another place. Very important. Energy travels. Yash Praveen, if there is a wave, unmute yourself, Yash Praveen. Wave, there is a movement of energy, right?
Yes, sir.
Whether the particles also move along with the energy?
No, sir.
Only energy moves from one place to another place.
Yes, sir.
Particles, what happens to particles then?
Sir, they keep oscillating, sir, and once the disturbance goes, they come to normal state.
Very good. So particle starts oscillating to and fro about its mean position, isn't it?
Yes, sir.
So good. So Pratap, can you please unmute yourself and tell me that
Yes,
what is the meaning of the word angular wave number? What is angular wave number?
Sir, I did not attend NST's class because
Okay, you are not there in this class. Did you see the
I was in
reading?
the previous class that we took called from 5 to 6 or something.
So you thought this class will not be there?
Yes, sir, I was not aware.
Fine. Did you take the notes?
And I also have my chemistry exam the next day, so I did not check the WhatsApp. So
Anyhow, that is fine. But did you take the notes of this waves chapter from the video? No.
not yet, sir. Oscillations I have took, but waves are not yet.
Okay, then take it fast before the next class I come back. Deepa.
Yes, sir, yes.
Deepa Jyoti.
Yes, sir.
Yes, I was asking about angular wave number. Can you please tell me what is the angular wave number?
2 pi by wavelength.
2 pi by wavelength. Very good. It is also called as?
Propagation constant.
Very good. To propagation constant. How it is represented, Pavitra? Unmute yourself. How we represent propagation constant? By which alphabet? Yeah. K. Very good. K is 2 pi by lambda. Okay. Shweta Shinde, tell me what is angular frequency?
2 pi by t, sir.
2 pi by t is angular frequency. Good. It is also called as? Angular frequency can also be called as? Angular velocity, isn't it? Angular velocity. Velocity is v, angular velocity is omega, isn't it? And 1 by t called as, what is 1 by t called as, Shweta?
Frequency.
Frequency, very good. What is the SI unit of frequency? SI unit of frequency, yes, hertz, very good. Nikas, if you can unmute yourself, and if you don't leave the meeting, unmute yourself and say, what is the SI unit of angular frequency? Mr. Nikas, don't try to play any tactics. Unmute yourself and say, I don't know. Yes. Oh, that's what you are going to do. I made your work easy. Yes, Nikas, tell me fast.
Sure.
Angular frequency SI unit. We are not waiting for seeing you combing your hair, man. Tell I don't know fast. Okay, now? Very good. Thank you. Jivika, unmute yourself fast. Say fast.
I don't know, sir.
Thank you. Abhinand, angular frequency SI unit. It is not in this chapter. It is coming from work energy in that chapter, rotational mechanics itself. Then also not knowing. Oh, very good. Yeah, Abhinand.
Angular frequency, sir.
Yes, man.
Hertz.
Oh, very good. Thank you. Hertz. Karthik, browsed up to now or not? Karthik, if you know the answer, please tell. Yeah.
Sir, Newton per meter square.
Newton per meter square. Where? Which world you went, man? Oh, that much bad condition. Shweta Karthikeyan.
Sir, can I answer?
I'll give chance to you. Aditya Raj. Some other question. Yes. Shweta Karthikeyan. Tell me.
I don't know, sir.
Sir, tell me.
I guess it's
No. Enough. Thank you. Yes, Aditya Raj.
Sir, radian per second.
Very good. Radian per second is for angular frequency. Then what is the unit of angular acceleration, Aditya Raj? First.
Hertz.
Hertz.
And
Angular acceleration. See, he browsed, no? if you say angular free velocity as radian per second, immediately you should say that angular acceleration is radian per second square. It itself shows that immediately browsed, got the answer, raised the hand and told the answer. Man, Aditya Raj, why are you like this, man?
Sir, no, sir, I didn't know.
Okay, then very good. If you know the answer, then I should appreciate also. Fine, anyhow. So with these things we learned in the previous class, the basics of wave, the wave frequency, wavelength, and what is angular frequency, angular wave number, all these things we studied in the previous class. Today we are going to start talking about equation of waves. Okay, from here the tough part of the chapter starts. Please. Angular? Radian per second. Radian per second. Yes. So coming back. So in this chapter, I said the tough part starts now. Now I am not making you afraid, tough part and all, for you to start getting afraid of this topic. No. Tough is a relative term. Tough is for whom? Who don't study. Right. The same question a person will say, easy question, but what is this? I did it very well. Other person will say it was very tough and nothing I understood. The difference between two people are, one person is studying well, so he is feeling questions are easy. One person is not studying at all, so he feels question is tough, right? So why I am saying this chapter is tough? Because relatively, from my experience, I have seen children not studying this topic properly and leaving marks here. So please be concentrated. Please understand what I am going to teach now. Then only this chapter will become strong for you. That is, you will become strong in this chapter. Yes, let us start talking about the equation of wave motion. So first you understand that I am drawing a wave here, right? So can I say that in this particular wave, the wave is traveling in x direction and y is the displacement of the particle. Can I say like this? Wave travels in x direction, and if I keep a particle here, suppose I am drawing a particle here, then this particle will be vibrating like this. Am I right? Do you agree with me? And this particle will vibrate in y direction. So displacement of particle will happen in y direction, and the wave will travel in x direction. Do you agree with me? But do you think that the function of the wave is only displacement, that is distance traveled by the wave? No, because even the time is changing. That's why it becomes complex. Here displacement is changing, distance traveled by the wave is changing, and time is also changing. Are you getting my point? So whatever this is representing, suppose I am taking this point, this is the point, that is, if this is the displacement, let me take this as y1 for x comma t, isn't it? Can I say like that? Because at this particular y1 point, it has travelled some distance x, and for travelling some distance x, it would have taken some time t. So can I say that there are two variables here? What are the variables? Distance travelled by the wave is also a variable, and the varying time is also a variable. Now, to understand it well, if it is just talking about distance and displacement, this graph is enough for you, this wave is enough for you, because we can see very clearly at a particular displacement what is the value of, at a particular distance what is the value of velocity, displacement, isn't it? If I ask you at x is equal to 2 meter, what is displacement? You will go 2 meter and draw a line and we will check how much is the value, you will see this is displacement. If I ask you at t is equal to 3 seconds, you will not be able to say, because there is no time axis here. Am I right? So for this what we do, see, there is a concept not there in the book much, but I am telling you about that. The concept is called as freezing of frame and video recording. Suddenly from where we get all these things? Nowhere in the subject. Freezing of frame and video recording. Now what is that? See, now what we are doing, the wave is moving towards x direction. We have taken a snapshot of that. Like we have taken a photo of that. That's why the wave is static. Or else what will happen? We will keep on moving towards right. If you are getting a static image of wave, only then you can talk about displacement and x. Because x is keep on changing, it's not going to stop. So what is happening here? Here we have drawn the function of y with respect to x. How? By freezing the frame. When the wave was moving, we have frozen the frame. That is called as freezing the frame concept. Second is, imagine that the wave is moving like this, okay? And what I do, I come in this direction of the wave. That is, wave is coming towards me like this. And now, I start my stopwatch here. X is equal to 0. What will happen for me? I will feel that something is rising up, then coming down, then going down, then rising up, then going up, then coming down. Are you able to feel it? What you'll be seeing, you know, you'll be seeing only this thing, nothing else. Because you cannot feel it is coming towards you since you are standing in this direction. Wave is moving like this. You can only see something going up, down, up, down, up, down. Are you feeling that? So now also you can find the displacement. How? Stopwatch is there, put 3 seconds. And 3 seconds, what is the height from the mean position? You can say that is the displacement. Am I right? That is called as video recording. It looks like that, isn't it? Looks like something is moving and you're recording. If I just show you, yeah. So you can see here, this is called as, yes, this is called as video motion. So in this case, the wave is moving. So where you must stand somewhere on this side to see. Are you feeling my point, what I am trying to convey it to you? You are seeing from this side, for your eye, the wave is moving from 0 to its amplitude, to 0 to minus amplitude, to 0 to plus amplitude, to 0 to minus amplitude. So you can see that displacement is varying with respect to time also. At the same time, in the above graph, freezing of frame, at a particular instant when the xi has this much value, what is the value of displacement also you can find. So what we come to know from all these talks, we come to know that equation of wave should be represented as a function of distance travelled by the wave as well as the function of time, how much time is spent. So for thinking about theoretically about time, it is about how the wave is moving and you are seeing from one axis, and seeing about distance and displacement, just taking a snapshot of it. I hope you have understood something in this. Okay, little theoretical topic, but I hope something has gone inside your head. Okay, so let us talk about the main part now. So what I am going to do, I am going to, I have taken a particular axis, x and y axis, where x are the particles, where I have 1, 2, 3, 4, 5, 9 particles I have drawn here, isn't it? And now what I am going to do, I am going to generate a wave from x is equal to 0. What will happen? The wave will start from the left hand side, it will start giving a wave motion to the particle. It means that the particle will start moving up and down, isn't it? Because energy is going to travel from 1 to 9. When energy travels from 1 to 9, particles will travel up or down. I hope you know this. So the same thing happens now. If I give the energy, now you can see 1 is here, 2 went in the upper position, 3 is here, 4 is down, 5 is here, 6 is up, 7 is down. If the wave is passing through it. So how this 2 will move? It will go from its mean position to extreme position, again mean position, again negative extreme, mean, extreme, mean, extreme. It vibrates like that, isn't it? Okay. Now you know very well from the last class that what is the meaning of wavelength. Wavelength is 2 consecutive points of same phase. In this case, 2 and 6 have same phase. So I can say the wavelength is lambda here between 2 and 6, and the velocity of wave I am taking it as v, travelling in positive x direction. So here, understand these things first, that amplitude I am taking it as a. Have you seen I have drawn? Amplitude is a, wavelength is lambda between 2 consecutive crest or trough also you can say, or you can say the points of same phase, and v is the velocity of the wave, right? So in this scenario, you know that what is the equation of displacement. From which chapter? From oscillations you know this. Y is equal to a sine omega t. It should not be new thing for you. In the previous chapter, if you have understood oscillations properly, you know displacement is equal to a sine omega t, where a is the amplitude, omega is the angular frequency or angular velocity, t is the instantaneous time. I hope you remember this thing from the previous chapter. Now, see something very important, please understand this. If you have doubts, stop me and ask, right? So now what I am trying to say, we know very well displacement of particle 1 from x axis is given by y is equal to a sine omega t. Now what? I am taking some distance x where the energy has moved from 1 to 6, okay, and I will try to find how much time the wave took to reach from 1 to 6. How much time it will take? Can you tell me without I write it? How much time the wave will take to reach from 1 to 6? Anybody? See the diagram and tell me how much time the wave will take to reach from 1 to 6.
Sir,
Yes.
yes, I guess
Is it wavelength by velocity, sir?
What will be that? Why you are saying wavelength here? 1 to 6 I am telling. No, whether 1 to 6 is wavelength.
Okay, it's not wavelength, the distance.
Yes, yes, very good.
So x by v.
Exactly, very good. Abhinand, I appreciate. So, how much time the wave energy will take to move from 1 to 6 is how much? X by v seconds. Do you understand why x by v? X is the distance travelled, v is the velocity, time will become equal to distance by velocity. Distance is x, speed of the wave is v. So, can I say that the wave reaches at the particle 6 at what time? X by v second, x by v time. Anybody has doubt in this? Manoranjan, understanding? I hope. Now something which is little fishy, please understand that. The wave energy started from 1 and it has taken a time x by v to reach here at 6, right? Can I say that the energy would have started at 1? If I compare from the 6th position, it is t minus x by v seconds. I will say this once again to you. Displacement of particle 6 from mean position at time t, I am writing as y is equal to a sin omega t minus x by v. See how it has come. I want you to understand this very clearly. I will take some time for this, but you should understand. Yeah. So, I was saying that the time taken by the energy to reach from 1 to this point 6, we have got it as x by v second. What is x by v? X by v is the time taken by the energy to reach from where? 1 to 6. So, displacement of particles, you know the equation of displacement, y is equal to a sin omega t. But this equation we took for which point? The first point, right? If I go to the previous page, there if you go, previous slide if I go, see. I took that y displacement of particle 1 from x axis is given by y is equal to a sin omega t. Remember that. So, displacement of 1 only we have taken as y is equal to a sin omega t. If displacement of 1 is y is equal to a sin omega t, then if I talk about displacement of particle 6 from the mean position at time t, that will become equal to t minus x by b as a time for that. I hope you are getting what I am trying to tell. This is the point where children will stop studying this topic itself. They will fail to understand how this expression has come. Y is equal to a sin omega t is known to me. I studied in oscillation itself. Suddenly you are saying y is equal to a sin omega t minus x by v. How you are writing, I am not understanding. This is the biggest trouble children have in this waves chapter. So you must understand it. Why I am saying t minus x by v? Because t is the time for the particle 1. So particle 6, it will reach after how much time? X by v, because x is the distance travelled by it. That's why I am writing the time taken by the particle 6 will be t minus x by v. So, tell me, Sharandra.
That t is for the first particle to reach that distance x.
That t is?
For the first particle to, for what, sir?
T is the time covered for the energy to reach from 1 to 6. Are you getting my point? Simple way if I say, when the particle started the motion, that time I am taking, right? So, that will become equal to a, at the point 1 it will become equal to a sin omega t. Now, for the 6th particle, how much distance it has travelled? X distance. How much time it has taken? X by v. So, for the 6th particle, the displacement from the mean position at time t will become equal to a sin omega t minus x by v. If this you understand, after that it is child's game. Anybody can understand. This, if you fail to understand, after this everything will become Greek and Latin for you. This should be very clear, and after this nothing. What I am going to do? I am going to put omega inside. So, you put omega inside, y will become equal to what? A sin omega t minus omega into x by v, isn't it? Omega I have put inside. Now, see what will happen. Y will become equal to a into sin. What is omega? What is omega? 2 pi by t?
Angular velocity.
Yes, what is that? 2 pi by t, isn't it?
2 pi by t.
Into small t minus omega is what? 2 pi by t, and here what you have? V you have, and above what you have? X you have. We also know that k is equal to omega by v, isn't it? We know this. So, since you know that k is equal to omega by v, I will try to use that in this term. That is, V can be written as omega by k. Can I write from here? V is equal to omega by k. I have taught this to you in the last class itself, how it has come. So velocity will become equal to omega by k. If you put velocity here as omega by k, it will become omega and k will go above, isn't it? So 2 pi by t, if I take outside now, y will become equal to a sine 2 pi by t has come outside, and what remains here? Small t remains here, minus k x by omega. Can I write like this? Now you don't copy anything. Next page I have all the notes written for you. So we'll go to the next page directly for you if you want to copy something from the board. See here. So yeah. What is the equation of y then? Y will become equal to a sine omega t minus kx. Now how it has come, I hope you are understanding. How suddenly this omega t minus ax came? Because y was equal to omega into t minus x by v, omega went inside, so omega t minus omega into x by v, where v is equal to omega by k, so that the omega gets cancelled, it will become equal to kx. So this is the expression. Expression of the equation of the wave is y is equal to a sine omega t minus kx. What is this?
I have doubts, sir.
Please ask me.
What is k in this, sir? What is k?
Propagation constant.
For that same k.
Exactly. Angular wave number or propagation constant.
Okay, sir.
Where k was equal to omega by v. Last class I told, no, Abhinand, do you remember? Please check, off that app thing. Yes, Praveen, what you are doing, man? Please. Yeah, coming back. What you are asking, Abhinand, you are clear in this?
Sorry, sir, it was an accident. Yeah, sir,
Okay.
clear, sir, got it, sir.
Okay, so k is equal to omega by v. Is it clear to you? So when I put the value of omega inside, I hope you are understanding how this term to this term has come. Clear, no? Omega has gone inside, and if omega goes inside, then here it will become omega into x by v, where v is equal to omega by k. Omega gets cancelled, so we will get a k into x. So we got the equation of y as a sine omega t minus kx. I will talk about this last thing that I have mentioned on the board. But first, this is clear to you, how y became a sine omega t minus kx? This is the equation of progressive wave in the positive x direction. It means that if any wave is trying to move in the positive x direction, then its equation is this, what? A sine omega t minus kx. What if a wave is moving in negative x direction like this? Then the equation of wave will become equal to y is equal to a sine omega t plus kx. Just change that minus to plus. This will become equation of negative x direction. Please remember that, because you put the value of x as negative x, it will become plus. So the equation of any progressive wave in positive x direction is y is equal to a sine omega t minus kx, and in negative x direction is equal to y is equal to a sine omega t plus kx. Is it clear to you? Both these equations are without any initial phase. I said you initial phase is if the wave already started with some angle. Why the wave has to start with the point x is equal to 0, the origin. The wave, why I start from here? If the wave is coming from this point like this, then this will become the initial phase phi naught. So if there is some initial phase, then we will add that initial phase in the equation. That's why the equation is y is equal to a sine omega t plus or minus kx plus phi. Omega t that is omega t minus kx plus phi is for the positive x direction with the initial phase as phi naught. I can write here as phi naught actually, yes. And if it is in the negative x direction, then the equation is y is equal to a sine omega t plus kx plus phi naught, whatever. Is it clear to you? With this understanding, if it is clear to you, first you can copy it. Anything you are writing, please copy it fast. If you are writing something from the board, make sure you have copied this. Make it fast, please. Don't take much time.
Sir,
Yes, Deepa, please.
can you just repeat what is phi again, sir?
Phi. I said about phi as initial phase, Deepa. I said that if a particular wave is moving with already having some angle, that is, it is not moving from the origin point, then whatever angle it had before it started the motion is called as initial phase of any particular wave. So in this case, if you take only this equation that I have written on the board, omega t minus kx and omega t plus kx, these two equations are only valid if the motion starts from the origin, right, Deepa? And if the motion is not from the origin, then you will have that initial phase added to the wave.
Okay, sir.
Is
So
it-
is it an angle, sir?
Yeah, it is an angle, obviously. It will be in radians.
Okay, sir.
See, this whole thing, that is omega t minus kx plus phi, the argument of sign, this is called as phase of any wave. Remember this. So in this case, omega t minus kx is the phase. In this case, omega t plus kx is the phase. In this case, omega t plus or minus kx plus phi is the phase. Understand that? Put me in this. Yeah. So I was saying that this term, the argument of the sine function, is what? It is the phase of any wave. So if there is no initial phase, then I can say omega t minus kx for the positive x direction, omega t plus kx for the negative x direction, and if the wave has some initial phase, then it will become equal to omega t plus or minus kx plus phi. Phi naught actually, that is the correct way of writing, plus phi naught, which is the initial phase. Is it clear, Deepa?
Yes, sir.
Sure? If yes, then the same thing I am mentioning here also, that the equation of a wave propagating in positive x direction is omega t minus kx plus phi, and for negative x direction it is omega t plus kx plus phi. Please copy it, it will be useful for many equations, many questions. Okay, I can also write the equation as this. You know how it came? Let me solve it here for you. So y in terms of x and t, the function of x and t, I have derived it as a sine omega t. What is omega? You are doing this before some time also. 2 pi by capital T into small t plus what is k? 2 pi by lambda into x plus phi. Can I write like this? Can I write like this? What I have done in this equation, actually I can write plus or minus if you want. In this equation, I have put the value of omega as 2 pi by t and the value of propagation constant as 2 pi by lambda. Now if I take 2 pi outside, then it will become equal to a sine 2 pi. What remains here? Small t by capital T plus or minus what remains here? X by lambda plus, since I take 2 pi common, 2 pi will come in the denominator, isn't it? So plus phi by 2 pi. This is also a way in which the wave equation can be represented. Now why this becomes important? Because sometimes the question will come where they will give you these terms and then you have to solve the answer in, find the answer in terms of either t or capital T or lambda. You have to use this equation only. So if suppose the initial phase would have not been there, then what will be the value of y? It will become equal to a sine 2 pi into t by t plus or minus x by lambda. Do you agree with me? T by t minus x by lambda for positive x direction, t by t plus x by lambda for negative x direction. These things should be in your head for this chapter. And again I am repeating, if you are understanding this, then there is nothing to mug up in this derivation. If you don't understand this, then there are a lot of things you have to mug up here. Leah Varshini, last 2 classes you have not attended, I think, right? You have missed the Wednesday's class, am I right? You have unmute yourself, please. You are muted. Leah Varshini, if you are hearing me, unmute yourself.
Sir,
Yes.
can you please repeat the other form of equation derivation once again, sir? The one which you wrote in bold just now.
Okay, you are talking about this equation.
Hmm.
What I have done,
Yes.
Shweta, what I have done, what is omega? You know omega is equal to 2 pi by t. Do you know this?
Yes, sir.
What is k? K is equal to 2 pi by lambda. You know this?
Yes, sir.
So what I have done, I have put the omega value as 2 pi by t here and k value as 2 pi by lambda here. Okay?
Okay.
Then I have taken 2 pi outside. If you take 2 pi outside, in this term what remains? Small t by capital T. In this term what remains? X by lambda.
X by lambda.
And in the third term there is 5, but I am taking out 2 pi outside. So I should divide by 2 pi, right?
Okay.
So I have divided by 2 pi. That's what I have written here. And what I wrote in this step is, if this initial phase would have been 0, that is, this term is not there, initial phase is not there. If this term is not there, then what we can write? We can write like t by t plus or minus x by lambda alone.
Okay, sir.
Understood?
Thank you.
Yes. So Leah Varshini, you are still not able to speak. You have some problem with the access. Okay. You call me after the class gets over.
Sir,
Yes, please tell me. Tell me, Manoranjan, please.
Sir, in our school syllabus, we studied that the phase difference is phase difference between the two waves, sine and cos waves, since it is a simple harmonic motion, sir.
Tell me again what you studied. Phase difference as?
Sir, the phase difference is the distance between the two waves, sine and cos waves, since it is a simple harmonic wave, sir.
No, what you are speaking is irrelevant to what we are discussing now. See, Manoranjan, phase difference means, please pay attention, phase difference means if there are two ways, that is, now we have not talked anything about phase difference till now, please understand that. We have just talked about initial phase. If you have two waves that are superimposing, then one wave will have phase difference as phi 1, another wave will have phase difference as phi 2. Difference between these two phases will only be called as phase difference. Are you understanding? Manoranjan? He dropped in the meeting?
Yes, sir.
Yeah. So now I will come to the topic. Next is that only superposition, where I will make that one wave is coming with equation y is equal to a sin omega t minus kx. Another wave is coming with y is equal to a sin omega t minus kx plus phi, and they both will be superimposing. When they both will be superimposing, that time phase of first wave minus phase of second wave, that will give you the phase difference between the two waves. Are you understanding the meaning of phase difference? And it will come now. It will come now. See, what you understand, sine, cos, what you are speaking, no, everything will come now. Don't worry about it. It will come. And then you ask me if you don't understand, okay? Let the phase difference come now. Then if you are not understanding, you can ask me. Fine? So, up to now in waves chapter, I have not talked about phase difference itself. After this only it is going to come. Fine. Shall I continue? I hope all of you have copied this. Shall I continue?
Yes, sir.
Sai Rakshana Harvish, please come back to the class. Yeah. So, same thing I said about the phase, initial phase. Now a basic question. Please make it fast. Very basic, very basic question is this. They have given a wave. The equation is 2, which is in centimeter, sine kx minus omega t, where k value is given as 2.11 radian per meter, omega is given as 3.62 radian per second, and they are asking you to find amplitude, wavelength, frequency, speed. That is damn simple question. So I'll ask you, directly I'll ask you, because the thing is there. Bhumesh, unmute yourself.
Yes, sir.
What is amplitude? Tell me fast.
1 minute, sir.
1 minute you don't need, man. See here. Yes. Tell immediately. If you understand the question, you can say the answer instantly. You don't need any time for this answering. Niranjan, please tell.
Sir, 2 centimeters.
Obviously 2 centimeter. Bhumesh, the equation is y is equal to, what is the equation? Y is equal to a sine what? Tell me equation, Bhumesh. Just now you learned no previous.
Omega t.
Omega t. Omega t plus or minus kx in this.
Plus kx.
Plus kx for which or minus kx for what? If it is traveling in positive x direction, it will be y is equal to a sine omega t minus kx. If it is traveling in negative x direction, then y will become equal to a sine omega t plus kx. Right, Bhumesh? If you are listening to the class.
Alright, sir.
I told this, no?
Isn't that formula slightly wrong there?
Let us check that, man. Why you are judging the formula before itself? Don't be so judgmental.
Omega t minus kx, right? Okay.
Okay, you are saying that how it can be, sir? No equation you wrote like this. Either it is kx plus omega t also is fine, but how it can be kx
yeah.
minus omega t? That's what you are thinking, Abhinand, am I right?
Yeah, that's what I'm thinking.
Yeah, because you are not knowing the basics of trigonometry. You know what is sine of minus theta?
Sine of minus theta.
What is this? Tell me.
Cos theta, sir.
Very good, man. Sine of minus theta is cos theta. Different, you are having your own trigonometry. Yes,
Yeah.
minus sine theta, obviously. Minus sine of minus theta is minus sine theta. The fourth quadrant sine is what? Negative. And sine of minus theta is what? In which quadrant? It is in fourth quadrant. I hope you are understanding it. Is it clear? So now, Mr. Abhinand, if sine of minus theta is minus sine theta, what will happen? What will happen? I will put here the equation as y is equal to 2 sine. If I write as minus inside, that is minus I am taking out from there. It will become omega t minus kx. And what I get outside? A negative sign I get. Isn't it? It
Yeah.
means that,
Got it, sir.
yeah, amplitude is negative 2 and now it came in which form?
Here in addition. Because
Yes.
it's going to be fine.
Positive x direction, isn't it?
No, it's going negative x direction.
What?
Cos.
Okay.
Cos are fine.
See, this thing should be very clear to you. Good that you are asking this doubt. Very good. But now you are clear in the question? So now Niranjan.
That's completely clear, sir.
Yeah, Niranjan, amplitude is actually 2 centimeter, but to be very exact, it is negative of 2 centimeter, isn't it? It means it is going in negative x direction. The amplitude is negative x, negative a, not positive a. I hope it is clear, Niranjan. So, what is the wavelength? Ivan Rufus. Yes, Mr. Ivan. Unmute yourself. Wavelength, fast. Unmute, I said we should unmute him instantly.
Sir,
Yeah. How do you find? Tell me that at least, man. Unmute and speak. Don't be muted. What are you doing? Pressing and removing. Press for 3-4 seconds. Yes. Now speak to me. Speak, Ivan.
sir, I have found the speed of the waves and I have found the...
Oh, without finding wavelength and frequency, you found speed itself.
Yes, sir. K is equal to mu alpha.
K is equal to 2 pi by lambda, right? This is the first thing. Right?
Sir, also K is equal to omega by V.
Yes, it is. This is. But why you want to go for that first? K is equal to omega by V. Before that, K is equal to 2 pi by lambda, right? This equation you know or not, Ivan?
Yes, sir.
So what will be lambda? Lambda will become equal to 2 pi by K. What is K? 2.11. So it obviously it will be in meters. So when you solve this,
Centimeters, sir.
why centimeter, man? It is 2.11 radian per meter.
Oh, okay, fine, sir.
Okay. So when you put in this equation, you will be getting the answer. Whatever, when you solve, you will get the answer. That will be the answer for lambda, isn't it? I hope you are understanding. Sanjeet, unmute yourself. Whatever. We will talk about that. Yes. Approximately 3 only it will come. Yes, Sanjeet. Tell me about what is frequency. Fast. What is frequency, Sanjeet? Which formula you will use? This much time you are taking. Leave it. This much time. Hey, Hemant, unmute yourself. How will you find frequency?
Omega by 2 pi, sir.
Very good. Omega will become equal to what? 2 pi nu, isn't it? 2 pi by t is only nu. So what will be frequency? Frequency will become equal to omega by 2 pi. Omega is given. Divide by 2 pi. Get the answer. Isn't it?
Sir.
Sanjeet, understanding?
Yes, sir.
Yes, Sai Rakshana. How will you find the speed of the wave? Tell me the formula that you're going to use. Already written on the board. Yeah, tell me fast. If you are listening to the class only, you can say the answer. Tell me fast, Sai Rakshana. Don't be silent. Wasting time. It is written on the board. K is equal to omega by V. K is known to you. Omega is known to you. Just divide omega by K. Get the answer. Omega is given as 3.62. K is given as 2.11. Divide both. Get the answer. Understanding, Sai Rakshana? At least say yes.
Yes, sir.
Yes. Thank you for saying yes. Is it clear to you? Very basic question. Very, very basic question. Nothing is there in this question. They are asking you to find amplitude, wavelength, frequency, speed. They gave everything in the question itself. It's like giving 3 marks free of cost to you. Enjoy your day to day. Like that is this question is. Can I go to the next page? If you permit me. Nikas, on your video, man.
Yes, sir.
Yeah, I'm asking question, you are disappearing for 15 minutes. Okay. Ate your samosa and came, Nikas? Okay. Shall I go to the next page? Say yes or no. Your people are stone or your human beings?
Yes, sir.
Thank you. So I'll move to the next page. So all the answers are mentioned here. And now comes the interesting thing. Manoranjan, be attentive. Your doubt came. Now we are going to learn about the principle of superposition and reflection of wave. Very interesting, very important, and the whole wave theory depends upon this only. So now, please pay attention. Okay. Now what is the thing happening here? If you try to feel, you will realize I am creating a disturbance. See carefully. There are two disturbances created. From which side? From the left side as well as right hand side. Can you feel? They both are traveling towards each other, and then they both interfered. They both went back. Again they came, interfered, they went back. Again they will come. See, they are coming, interfering, becoming, and then once again coming back. Again they are going. Are you feeling what is happening? There are two waves traveling here. One from which direction? Left hand side. One from right hand side. And when they are intersecting each other, then you could have seen that in the first case what happened. In the first case, there was a double amplitude taking place. See here? See here what happened. Do you feel that? The amplitude of both the waves became double when they were interfering with crest and crest. See, there are multiple possibilities. If I draw the diagram, you will realize it. Let me draw the diagram here for you. Now please see here. If one wave is coming like this towards x direction, one wave is coming like this towards negative x direction. Now when they are going to interfere and hit a particle here P, this particle has three possibilities. One possibility is that when the crest of the first wave is coming, that time the crest of second wave also is coming. Then the final amplitude will become crest plus crest, double the crest. Am I right? It will become two-way. Second possibility, crest of first is coming, trough of second is coming. Crest plus trough 0. Net displacement will become 0.
Sir, but that happens only when the two waves are only opposite in direction.
Yes. If they are in same direction also, there are possibilities, no. They are, see, it's all about when they are meeting, which part of the wave is meeting. If crest and crest is meeting in same direction also, it will become double the crest, no. If trough and trough is meeting, double the trough. If crest and trough is meeting, 0. Or maybe that some random point meets, suppose some y1 from here is meeting and some y2 from here is meeting. Random also can meet. But whatever is the displacement of the particle, if its amplitude is a1 and its amplitude is a2, then the displacement of particle P can be either a1 plus a2 or minus of a1 plus a2. That is, either it can be, suppose 2 centimeter and 2 centimeter, they are going and interfering. It can be plus 4, minus 4. It cannot be anything more than plus 4. It cannot be anything less than minus 4. Do you agree with me? If crest and crest is intersecting, it will become 4. Trough and trough, minus 4. Any other part, it will become 1, 2, 3, minus 1, minus 2, minus 3. Are you getting what I am trying to tell you? When two waves in opposite direction are interfering with each other, the possibility can be, it can become double the amplitude, either in positive direction or negative direction. That's all it can be. That is plus 2a, minus 2a. Within this only it will be. That's why I told, if it is 2 meter hitting each other, it can become plus 4, minus 4, 0, 1, 2, 3, minus 1, 2, 3. These are the possibilities, am I right? Is anything else possible? Is 5 possible? Impossible. 2 and 2 is meeting, how it can become 5? Is minus 6 possible? Not possible. Because minus 2 is meeting, minus 4 is the minimum possibility. It cannot go below minus 4. I hope you are getting my point. That is what you are seeing in this representation also. In this representation, if you see carefully, you will realize when the two waves are meeting, multiple things are happening. Sometimes, like see first time they both, double it became, you saw? And now see, it will go back, once again it will come back, that time what will happen, you see? Became 0 for an instant, once again going back. Some part it is becoming, once again it is coming, double it became. Are you feeling? So multiple possibilities can happen. It can become double the amplitude, positive, double the amplitude, negative, 0, or some random value of the displacement. In simple way, if I say the displacement of any particle will be the addition of displacement of two particles. Can I say like that? And which displacement? Vector displacement, vector addition. Because displacement is a vector quantity. Don't add algebraically. It should be added following the vector rules. Coming back. So, once again the same thing they are saying. If one wave is having y1, another is having y2, when they interfere, then the net displacement will become equal to y1 plus y2. This is only called as principle of superposition. That is, net displacement of the wave after two waves are interfering with each other is the vector addition of their individual displacements. Write that. Please copy this up. On the board it is mentioned. What you should write? The resultant displacement produced by a number of waves is the sum of displacements produced by each wave. This is only known as principle of superposition. It may come in 2 mark or 1 mark definition also it may come. What is principle of superposition? Resultant displacement produced by number of waves is the vector addition or the vector sum of the displacements produced by each of the waves. Displacement produced by each of the waves. This is only called as principle of superposition. Can I go to the next page? Shall I?
Just a second.
2 minutes. Sir.
Yeah, okay. Why panicking? I'm going to ask you only and go fast. Anshul prepared for computer science?
Sir, tomorrow is chemistry.
Oh, tomorrow Tomorrow is chemistry.
Me too, sir.
Okay, okay. I thought computer science tomorrow. Fine.
I have maths tomorrow, sir.
Oh, good, Pratap. People are coming despite of other exams. Happy.
Tomorrow is computer science, sir.
Sugandhan, you also came, man. And now only I am seeing you. Surprise, man. Thank you for coming, Sugandhan. I should thank you only. During exam, you have come means it is a big task. What, Sugandhan?
Yes, sir.
Yeah, he's saying yes, sir. No shame at all. Hey, you should not miss the class like this, man. For small examination. Okay, coming. Shall I go to the next page? Abhinand, done. Thank you.
Yes, sir. Done, sir.
Now, see. Once again, we are talking about two waves moving in opposite direction. Can you see? These two waves which are coming, when they, after 1 second, where they will reach like this. One step ahead of where they were. After next second, they will reach one more step. What will happen now? Crest and trough is meeting. What will happen? Displacement will become 0. 4 will remain in the same place. So what is the resultant displacement here? 0. Trough have met together, it has resulted in 0 displacement. If crest and crest would have come, it would have become double the displacement. If trough and trough, negative double. I hope you are understanding what I am trying to tell. So resultant in this case became 0, and why it became 0, I hope you are understanding. Okay. Now we are entering into the interference of waves, where whatever we learnt about superposition will be applied to form a new wave pattern. Now we are going to enter into the standing wave formation. Very interesting topic, standing wave formation. I will talk about that in detail. So first you understand that if first wave is having the equation a sin kx minus omega t, and second wave is having an equation y2 is equal to a sin kx minus omega t plus phi. That is, it is having some initial phase phi, and so it has a different equation y is equal to a sin kx minus omega t plus phi. So there are two waves. I have drawn two waves, one in red color, one in blue color, and they are having different wave equation. So obviously, since it has, you can see here, somebody was asking about phase before some time. You can notice that phase is this much different from both, isn't it? So since this wave started at this point, it has a different displacement at this instant, at t1. This wave will have a different displacement, isn't it? It has displacement y2 and this has displacement y1. Are you able to feel that? So now, if these two waves are going, you know by the mathematical formulation that net displacement will become equal to what plus what? y1 plus y2. And here, see, please pay attention. If I would have started my wave like this from this point, I'll use a different color, maybe, yeah, blue color I'm using. If I would have started my wave like this, now see what would have happened. Here trough is coming, here crest is coming, 0. Here trough is coming, here crest is coming, 0. Here crest is coming, trough is coming, here crest is coming, once again 0. I would have got no displacement of the resultant, am I right? If I would have drawn a wave like this, one wave like this, another wave also having the same point of origin, what would have happened? Here a plus a will become 2a, here minus a minus 2a, again a plus 2a, again minus a minus 2a. What I am drawing, what they have drawn here is the third possibility, that some part of the first wave and some part of second wave are meeting. So they will produce a wave which has a displacement of what? y1 plus y2. It will not be double amplitude, but it will be y1 plus y2. So that's what they will write here. See, displacement will become equal to whatever is the y1 here, whatever is y2 here, they will add both, that will be the net displacement, isn't it? Okay. Now, y1 you know, y2 you know, and you know very well that the principle of superposition says that net displacement will become equal to y1 plus y2. So now comes the trigonometry. I hope you remember, without you start browsing. Yash Praveen from browsing, I remember. You have to meet me today. I told you to meet Wednesday itself. Yes, Praveen, there in the class or went somewhere? Not there, no. Before itself he left. Okay, if he comes back, let me know, okay? I am telling to Shrey. If he joins back, please let me know. Yes, Praveen. Okay, fine, coming back. Don't browse the answer, fine. So, what is the mathematical expression of sine A plus sine B?
2 sin A plus B by 2 into
Cos
A
A plus B by 2. Huh? Yes, Varshika. So, 2 sin A plus B by 2 cos A minus B by 2. Is she correct? Here two people are sitting, Sharan and Varshika, they have told sin A plus sin B is 2 sin A plus B by 2 into cos A minus B by 2. Do you agree with what they have told? Deepa?
Yes.
Yes. I also agree. So now what will happen? We will use the formula, and when the formula is used, now they have directly written the answer. We should find and get the answer. See. So what will happen here? This A, y will become equal to A, if I take common, sine, this term I am taking as A, this term I am taking as B. Abhinand, you know these things? Sin A plus sin B is equal to 2. Now you know, right? At least for this question you understand this identity. You should know these things, man. Pure science means what? You will not study. Huh?
I don't know when to learn it, sir.
Very basic things, man. Not how to learn. You should learn by taking efforts.
They didn't teach me in 10th, sir.
Okay, you meet me separately. Now let us proceed in the question. So
Fine.
A I should write sine. Sine. Why I wrote this bracket? Okay. So A sine A plus B by 2. What is A plus B? Kx minus omega t plus this value. So I am writing it as like, or I can, for easy calculation, I will take this as A and this as B. It will be easy to calculate, nothing else. It will save my time. So it will become Kx minus omega t plus phi plus Kx minus omega t by 2. Do you agree? And cos, 2 also is there outside, cos Kx minus omega t plus phi minus Kx plus omega t by 2. Am I right? In the cos term, Kx cancels, omega t cancels. Here nothing cancels actually. So what will y become? Y will become equal to 2a sine, what is this? Actually I can write 2kx, or I can write, like this, 2 into kx minus omega t plus phi by 2, whole by 2, and this cos, only phi by 2 will remain, into cos phi by 2. Very poor handwriting I am using. So I will write here little neatly for you people. Y is equal to 2a cos term I will write first. What is cos term? Cos phi by 2, isn't it? Into sine, I got kx minus omega t plus phi by 2. Can I write like this? Manoranjan, especially you, because you have some trouble in this. Is this clear to you? Whatever I have done in this step is clear to you, how I have done?
Sir, from first, can you
Yes,
repeat
sir.
this process, sir?
Whatever I did now. You know the identity, right? Sin A plus sin B identity, Sharan Ram? Yes. So 2, here what is there? Sin A is there, sin B is there. So I have taken 2 sin A plus B by 2 and A minus B by 2. I have taken A as kx minus omega t plus phi and B as kx minus omega t. So kx minus omega t plus phi plus kx minus omega t divided by 2 I have done. Obviously. And then once again kx minus omega t plus phi minus kx, it will become plus omega t divided by 2, isn't it? So kx gets cancelled, omega t gets cancelled. What remains here is only phi by 2 with cos. So I wrote cos phi by 2 before. And with sine what remains? 2, yes, it will get cancelled. Oh, very good. 2 kx minus omega t plus phi whole by 2 is there, no yaar? Whole by 2 is there. So only for this term I am taking separately. What you are talking, Varshika? Understood how it came? It is whole by 2. So for this term 2 gets cancelled. For phi by 2 remains, no? So it becomes plus phi by 2. Is it clear to everybody who is there in the online?
Yes, sir.
Because this only they wrote finally. They have not derived all this much, and finally what they wrote the expression, I am erasing this, you can do it by yourself, nothing big in this. They have written finally 2a cos phi by 2 into sine kx minus omega t plus phi by 2. Is it clear to everybody? Is it clear to everybody what I have written here? This is the expression for resultant of two waves which are interfering with a phase difference of phi. Why I am saying phase difference of phi? Are you getting Manoranjan? I am saying phase difference of phi because it has a phase of kx minus omega t, it has a phase of kx minus omega t plus phi. So what is the difference between their phases was only phi, right, in this case. I hope you are getting my point. Okay. Shall I proceed further? Can I go to the next page if you allow me?
Yes, sir.
Okay. So if I
Sir,
go,
one minute, sir.
yeah, make it fast, make it fast, make it fast. Can I proceed now?
Yes, sir.
Okay.
Sir, 1 minute, sir.
I'll wait, Gokul. Thank you, Gokul. Shall I proceed further?
Yes, sir.
Okay. So now, if you see this term, don't you think it looks like some y is equal to a sine omega t, that is this term becomes like some kind of amplitude? The general equation of a wave is y is equal to what? Amplitude times sine omega t, isn't it? So can I say that term 2a into cos phi by 2 is some kind of amplitude? So we came to know that resultant amplitude of these two waves is how much? Resultant amplitude is 2a into cos phi by 2. Do you agree with me? Do you agree with me? Yes.
No, what you are saying is,
Yes, sir.
like the equation y is equal to a sin by t.
Hmm.
A in this equation is 2a cos.
Exactly, exactly. In this equation, superposition equation, the amplitude is 2a into cos phi by 2. Clear? Okay. Now, the same thing they have mentioned here. Now, what I am going to tell you, now this is the topic which is going to repeat in 12th. Same topic. There also we will write constructive interference, destructive interference. Constructive interference will form bright spots and destructive interference will form dark spots, or we call it as blind spots. We will come to that in 12th, but now you understand what is the meaning of constructive interference and what is the meaning of destructive interference. In simple word, if I say constructive interference is that point where the resultant amplitude is maximum. Okay? If the resultant amplitude is maximum, that is known as constructive interference. If resultant amplitude is 0, that is called as destructive interference. Not minimum, I said, 0. Because many children will think, okay, plus 2a constructive, minus 2a destructive, not like that. Plus 2a and minus 2a, both are constructive only. When the amplitude is 0, that is called as destructive interference. Is it clear to you? So for constructive interference, what I will say? For constructive interference, I will say when two waves are interfering in such a way that their amplitudes becomes double, that is a plus a will become how much? 2a, isn't it? A plus a become 2. This kind of interference is called as constructive interference. And when a and minus a meets, that is crest and trough meets, that will be called as destructive interference. Now, you know the equation of the wave. The equation of wave is y is equal to 2a cos phi by 2 into sine kx minus omega t plus phi by 2. So now tell me, for this A to be maximum, in these terms, this cos phi by 2 should be maximum, isn't it? For this amplitude to be maximum, what should be maximum? Cos phi by 2 should be maximum. And if you want cos phi by 2 to be maximum, what has to be done? The maximum value of cos, that is A, is plus or minus 2A, isn't it? In this case, what is the maximum value of amplitude? Plus 2A or minus 2A? I hope you are understanding this. So, if it is plus or minus 2A is equal to 2A into cos phi by 2, 2A gets cancelled. And what will happen to cos phi by 2? Plus or minus 1. Now, tell me, which value of cos gives plus or minus 1?
Sir, cos 180 or cos 0?
Cos 0 is how much?
1.
1. Cos 90 is how much?
0.
But there is no 0 here. So, we should not talk about 90 here, isn't it? So, cos 0 is 1. What is cos pi?
Cos pi is 180, sir.
What is value
Cos
of
pi is negative 1.
negative 1? Very good, very good, very good. Negative 1. Negative 1 once again is the value of maximum amplitude, right? What is cos 2 pi?
Again 1, sir.
Very good.
Again 1.
What is cos 3 pi?
Negative 1.
Very good. Cos 4 pi? Cos 5 pi?
Minus.
It means that whether it is going to be cos which pi? 0 pi, plus or minus 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, all these values are going to give you plus or minus 1 only. So, can I say that phi by 2 must be equal to 0 plus or minus pi, 2 pi, 3 pi, 4 pi, like that? And then 2 goes this side, it will become 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, that is in general I can write it as 2n pi. Now understand that if two waves are coming and they are interfering with each other, when they are interfering, the phase difference between them is 72 pi. 72 pi. It is coming in the category of 2n pi or not? Yes, coming. It will be giving you a constructive interference. If they are meeting at 71 pi, we cannot comment now because we have not learned destructive interference. But it will not be constructive, we are sure. If two waves are superimposing each other with a phase difference of 36 pi, what it will be? Constructive. If they are interfering with phase difference of 21 pi, not constructive. Destructive we will learn now. Is this clear to you? So, what you should retain from here is the equation. The equation for constructive interference should be phi must be equal to 2n pi, where n starts from 0, 1, 2 and so on, isn't it? So, when two waves are interfering with phase difference of 2n pi, 2n pi means either 0 or 2 pi or 4 pi or 6 pi or 8 pi or any even pi, then you are going to have a constructive interference. I am repeating this, very important for 12th standard. Now still you are learning, if you are learning properly. Can I go to the next page? Fast. Fast. Yes, Praveen? I want to meet you today itself.
No, sir. Sir, will come.
After the class gets over, I'll give you 5.
Yes,
How
sir.
much time you will take to come here? How much minutes?
15 minutes I'll come, sir.
Okay. So, I'll end the class in 5 minutes, then you can start from your home after ending the class. Okay.
Yes, sir.
Okay. So, can I proceed further?
Yes, sir.
Yeah. Please, you have to copy. I'll share the link when you copy later, or if you want, I'll share the PPT also, you copy from there. I am running out of time. Okay. I'll just go to the next page. You can copy later. Either by seeing the video you can copy, or if you want, I'll share the PPT with you. You can copy from there also. Okay. Shall I move ahead? Understand the concept is nothing very big I am doing. Can you go to the next page, please? Permit me.
Yes, sir.
Thank you. So now we will talk about destructive interference. Somebody wants to ask something? I don't think. Okay. Destructive interference. I told you what is the meaning of destructive interference. If two waves are meeting in this way, crest of one wave, trough of another wave, what will happen? The net amplitude will become plus a minus a. What will be that? 0. You are going to get a straight line. There is no wave going to form because crest, trough, 0, 0, 0, 0, 0, 0. No wave will form. And if so, the amplitude is 0. Now once again I will write the same thing. 2a cos phi by 2 should be 0. For what? For destructive interference. Now which value of cos will give 0? 90?
Cos 90.
Only 90?
Cos 270.
Cos 270 then?
Again, every angle, sir. Pi
Yes.
by 2, pi 3 by 2.
5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 27 pi by 2. Am I right? Can I say like that?
Yes, sir.
Yes, I can say like that. So if that happens, I am writing the 5 by 2 values as pi by 2, 3 pi by 2, 5 pi by 2, and then when I multiply that 2 that side, it will become pi, 3 pi, 5 pi, 7 pi, 9 pi, isn't it? So it becomes 2n plus 1 into pi if n starts from 0, isn't it? So what we come to know, if the phase difference between two waves is 2n plus 1 into pi, where n starts from 0. Put 0 here, it will become 1 pi. Put 2 here, it will become 3 pi. Actually 1 here, put 3 pi. 2 here, 5 pi. 3 here, 7 pi, like that. So when you are going to have odd multiples of pi as the phase difference between two waves, and when they are going to interfere, it is going to give you a destructive interference. It means there is 0 amplitude. Is it clear to you? When two waves are undergoing destructive interference, if their phase difference is odd multiples of pi. When two waves are going constructive interference, when their phase difference is even multiples of pi including 0. I hope it is clear to everybody. If anybody has any doubt, please ask me. Yeah. Any doubt is there? I hope not. We are slowly entering into the interesting part of this chapter, which I will be doing in the next class. I will meet you once again on next Wednesday if I am right. And there we will try to complete waves chapter. Today I am ending little early, but next class I will be continuing and we will be try to complete this chapter. Okay? With this knowledge only we will proceed. That time I will not teach you once again all this derivation. Fine guys? So I am ending a bit early today. Anyhow, take care. Bye bye. The PPT if you want I will share with you. Notes I will share with you. Video I will share with you. Everything is in your hand. Whenever you want you can copy the notes. Whatever you want you can do with that. Okay? So with that I am taking a leave. Take care. Bye bye. The screen will be there for some time. You can copy the notes if you want to copy.
Yes, sir.
Yes. But I am leaving. Take care. Bye bye.
Thank you, sir.
Yeah. Bye bye. Yes, Praveen. Drop off and come soon.